Welcome back, everyone. In this video, I want to talk about code splitting and chunking, React Lazy, as well as React Suspense. These are all things that you may have heard in rather recent versions of React, and when you're curious about what they are, they're really just ways that we can optimize the way that our browser downloads the code that we are serving from our website. If you were to look inside of your network tab, I just recently refreshed the website on the homepage, and I want to show you what you see here. So I'm going to remove some of these handles. A lot of what you see here, there are images, there are some different code blocks, some of them being from our Stripe library, some of them being from our own application. But the main thing that you'll really notice is that there is this CSS, which comes from Google API, which is, of course, our Google fonts. We have this bundle.js, which gives us the big bundle of all of our application code. And then there is a bunch of Stripe-related code and some font-related code related to TypeScript for fonts. There's essentially a lot of different library code. The key thing is the bundle.js. The bundle.js is a bundle of all of our JavaScript. If I were to clear this out and navigate to different parts of the application, all of these calls that you see here, these are all for Firestore. This one is for Stripe. These are all images. This one again, Stripe, and this one Firestore. Nothing is being called from our application. If I clear this again and go to the authentication page, we see that there's no downloads. Again, other than a Stripe one. Stripe does its own thing. It's not really important for us. What this means is that when we come to our application for the first time, we are downloading the entire bundle of our application right out the gate. This is very inefficient because as we scale our application, our JavaScript code is going to get rather large, which means the load time it takes to download the entire bundle of our entire application is going to be costly. Why is it that when I'm on the home page, I want to download all of the JavaScript and React code for the sign-in page or for the shop page or even for the checkout page? None of those are important to me right now. The only thing that I should need is just the home page. And this is the whole idea of code splitting. By code splitting, we tell React and Webpack to split up our bundle into the appropriate quantities. Meaning that if I land on the home page, just give me the home page stuff. If I land on the shop page, just give me the shop page stuff. If I land on authentication, then give me authentication. So that is what we're going to do. We're going to use a combination of React Router as well as React in order to split our code at the route level. To do this, we need to use a couple new concepts. The first of which is that we are going to be using React Lazy as well as React Suspense. Both of these are required in order for us to do something known as dynamic imports. Dynamic imports is something that comes from modern JavaScript. It's a modern JavaScript feature. When you do an import like this is a synchronous import, meaning that your JavaScript code is not going to run until all of these imports are successfully brought into this file. Then it proceeds and actually renders and runs the rest of the JavaScript code. With a dynamic import, it's kind of like an async await. The way it's written, if we were to take this home component, for example, and turn it into a dynamic import, you would say const home is equal to await, and then inside of the await, or actually after the await, you would say import and then the route that you are importing. Like so. That's how we go from this style of import over to dynamic import. But the problem is that inside of React doesn't actually know how to utilize this. You need to use a combination of React Lazy and React Suspense in order for this to render. So how do we convert this over to React Lazy? So the way that you would utilize React Lazy is that instead of writing the await statement, Lazy is actually its own function. It will return you back a modified version of this component when it receives it. So what you pass to Lazy is a function with the import statement. And now this is a lazy component. Essentially, React will not render this until it actually fetches it when it's required. When is it required? Well, on the page that actually renders and it sees that this is a lazy import is when in the browser, the moment it encounters this, it's going to start requesting for this component from our server that is hosting all of our code. Unfortunately, in order to use it, we need to use React Suspense, because Suspense is essentially saying, hey, I know that you are currently trying to fetch something in suspended animation, meaning it's asynchronous, some component. While you're waiting, what do you want me to do? What do you want me to render? So here, what we can say is that, okay, if one of our routes or any of our code inside of this is being lazily loaded, then what we're going to do is instead show the spinner component. So here, let's import in spinner from our components, our spinner, and then our spinner component. And then for suspense, all we say is that, okay, suspense takes one value, which is the fallback. And the fallback is where you render the component you want to show when things are loading. So now if we save this and we come back to the application and let's refresh, you see the spinner and then you see everything load. But what you notice inside of this code, let me filter this down to JavaScript only. We have this new additional source routes home, which is coming from our website. And that is what is happening. When you land on the home page is when it actually tries to fetch the home component. If you are on the shop page, and let's say you re-rendered the entire application from scratch, notice how we're not pulling anything related to the home page. We get the bundle.js, of course, which is the appropriate bundle of the relevant code. But if we come now to the home page, there we see we actually finally then download the home component. So now it's very easy because at the route level, we can now very quickly wrap the appropriate route components inside of a lazy check. So now I'm going to say const authentication is equal to lazy import of this route. And now I can get rid of authentication. And if I save now, and I come back to my application, and I force a refresh, initially on the home page, we download our initial bundle, as well as our home component, because that's what we need. But when we go to sign in, is when we download our authentication. Notice that the bundle is 740 kilobytes. What I want to show you is that as we start splitting out this bundle, this size should theoretically get smaller because the initial bundle should grow smaller. So let's go back and let's start converting any of these relevant route components over to using our splitting. So I'm going to do the navigation component as well. In fact, let's just do these three right here. We need the spinner to be synchronously loaded because that is our only fallback component. So this one very clearly doesn't need to be a dynamic import. But these other ones like navigation, lazy, import, and then copy over this route. In fact, I think I can do this more efficiently, like so. Wrap this, get rid of this, wrap it in lazy, and then we need to wrap these also inside of an import. And now if we save, let's go back to our application once we tidy up some of this spacing. And if we refresh, let's look inside of our network. We do see that our bundle size has reduced. We see it's down to 728 now. Now that number should only get smaller as we continue to code split dynamically imported route level components. So that's it, really. You've learned the majority of the different strategies that React provides for us when it comes to optimizing our performance. We can optimize at the callback level. We can optimize with hooks. We can optimize with React Lazy and React Suspense, as well as dynamic importing. But really, that covers the breadth of the strategies that React has available for us when it comes to performance optimization. I do want to mention once again that throughout this course, you have been learning a lot of the best practices and patterns of how to write optimal and performant code in the first place. Beyond that, we are also really focused on understanding the rendering and re-rendering cycles that exist inside of React as well. With all of that combined, you are now very equipped to begin writing beautiful and performant React applications. So that covers it for our performance section. Thank you, and I'll see you in the next video.